This video is about the implementation of selection sort and bubble sort of sorting algorithms. The first one is selection sort. It basically goes through the entire array, looks for the smallest, and then puts that into the first position. The first one is selection sort. It basically goes through the entire array, looks for the smallest, and then puts that into the first position, and so on.
Given this sequence, the code will look first at 4 and store it as the smallest. It will then look at 2, and since 4 is greater than 2, it will store 2 as the smallest. Since 2 is less than 3, 2 is still the smallest. Since 1 is less than 2, 1 is now the smallest. Since 1 is less than 5, 1 is still the smallest. As we get to the end of the series, 1 is the stored smallest. So 1 will now be switched into the first position, its final position. This repeats for the next iteration, where it will eventually find 2 as the smallest and put it into the second position, which is its final. By the third iteration, the sequence is in order, but the computer doesn't know that, so it will go on and consider 3 to be the smallest. Since 3 is less than both 4 and 5, by the last part, 3 will be placed into the third place as its final place, which it is in already. And it will do the same to process 4 and 5. By the last iteration, the computer will recognize 5 as the end of the set, and therefore it is already a given that it will stay, since all the ones smaller than it should have been sorted by then, and that's when the computer considers it properly sorted.
Linear sort is efficient for smaller lists, but tedious for large lists. Its best case scenario is also its worst case scenario, which gives it a running time of n squared. This is because none of the loops in the code are dependent on the number of elements in the array to be sorted. Let us now consider the bubble algorithm. The basic premise of the algorithm is to compare 2 consecutive items in the set and switch them if the first one is greater than the other. This repeats for the entire set as long as at least one switch has occurred. Using the same starting sequence we used for linear sort, let us now sort it using bubble. Since 4 is less than 5, no switch occurs. Since 5 is greater than 3, a switch occurs. At this point, it is guaranteed that bubble will look through the set again to sort it. As the algorithm reaches the end, it looks like this. This process continues with the second iteration and the third iteration. By the end of the third, the sequence is sorted, but bubble sort needs one pass without any switches to consider the array sorted. Bubble will only return the array after one more iteration, the fourth pass. The best case for bubble sort is a set that is already sorted because it will not switch anything on the first pass, giving it a linear running time. Its average and worst case running time is quadratic. In summary, linear and bubble sort are 2 algorithms you should consider if your list contains only a few elements. They are also easy to understand and code. Yay!